Hello everybody and welcome to Let's Code for the older folks. My name's Les Thatcher. Nice to have you with us. And carrying on with our MicroPython. Today we're going to be looking at a thing called interrupts, where I'm going to be introducing you to interrupts. Now they're useful because it helps make things happen automatically on our microcontroller, our ESP32, right? And it helps solve a lot of timing problems. With interrupts, you don't need to constantly check what the current pin value is, all right? And when a change is detected, an event is triggered, and it's what we say a function is called. So when an interrupt happens, the processor stops the execution of the main program to execute a task and then gets back to the main program. Okay? It's called interrupt handling routine. Interrupt handling routine. So first thing we'll do was set up the circuit. So let me go back to here, overhead. What I'm going to introduce you to today is called a PIR sensor. PIR sensor. Got 3 pins. Again, live, signal, ground. Now on the back, if we look here, if you can see, got 2 like here dials. Get my pointer. Here, 2 dials that you can turn with a screwdriver. Now from my quick bit of research, they are for sensitivity and the angle of the sensor. So really the distance and the angle. I haven't touched anything. I've left everything as default. All right, I'm not quite sure what one does which. Once we've set this up, I will play with it and discover which one does which. Then there's a jumper. Right, we can see that jumper. And that jumper I've just left again, default. Right, I haven't touched anything. Right, so that's our PIR sensor. Let's go to the schematic. All right, so let's follow the schematic as best we can. All right, so first thing I'm going to do, get my sensor and plug it in. Exactly the same as it is in the drawing. So ground, signal, power. Right, just the other side of the trench. I'm going to just put this like that for now. Right, just out of the way. Let's make sure it's out of the way. Yeah. Okay. And then I'm going to carry over the wires. So I want a black wire. Now what I'm using here are male to female cables. You'll need 3 male to female cables. Then I'm going to go from the ground. On the ground, yep. I'm going to go behind and make this as neat as possible and go to my ground rail. Like that. Henry Cooper would say. And what I'm going to do then is take the red, okay, take it to 3.3 volts. Yeah, 3.3 volts. To my 3.3 volt. I'm going to take my yellow in the middle, okay, and I'm going to take that to pin 14. Right, my old eyes. It's up here on this side somewhere, pin 14, which is just So that's that one. Now, the next circuit we need to build is the LED. Okay, so we'll do our LED here. I'm putting the long leg, right? The long leg of the LED to my right hand side. Okay. Then take the blue cable, going from my long leg to pin number 12. It's right next to 14, so we're using pins next to each other. Right? We're using pins next to each other. Next thing I need is a 330 ohm resistor. 330 ohm resistor goes from the left leg across the trench, right, of the LED. Yeah, dory. Then from that resistor, other side of that resistor, I'm going to take that to ground. All right, you can see that. Right, dory, you can see that circuit. All right. Pause the video and just copy the drawing. Just copy the drawing. Right, let's go over to our Thony IDE, Integrated Development Environment, and let's have a look at the configuration. Right, the sketch. Right. Remember, I'm using my main.py, okay, file. Right, I use main.py all the time. Remembering as you save these configurations, save them to your computer. I'll just remind you how you do that. File, save as, it's computer, name it something else, all right, that you want, okay? But for now, I always save mine to the MicroPython device, all right? And I call it main.py. The boot.py is your firmware, your operating system, in case you didn't know. Okay, let's move on. Right. Stuff we've done before from machine, right, import pin, capital P on the pin, right, enter, from time, import sleep. Right, we've done them two before, we need them for later on configs. Now, what we need to do is set the motion. Right, motion equals false. Capital F on the false. Okay, enter. I'll quickly talk you through this code once we've typed it all out. Okay, that's the best way to do it. Now we want it to define DEF handle underscore interrupt. Interrupt is double R, isn't it? Interrupt and brackets on, and it's pin, small case this time. Okay, small case. So def handle underscore interrupt colons gives us auto indent. Then we want global motion, enter. Motion, so this is if the motion equals true, capital T on the true, enter. Global interrupt underscore pin. Small case on the pin. All right. Underscore. All right. And I've done that the same with true, yeah, equals underscore pin. That one, enter. So remember to keep these tabs in place. Interrupt underscore pin, all case, space equals pin. Right, so that's that 5 line. That's to handle the interrupt. Right. Now we need to name our variable. So LED equals capital P on the pin, brackets on. Remember to put that on pin 12, our LED, comma. And it's an output, so it's pin dot out. All capitals. Right. Brackets off. Enter. PIR equals pin, capital P on the pin, brackets on. Remember we put that on 14. Then it's comma. And it's an input. This time it's an input. Capital in. All right. Brackets off. So far so good. Enter, enter. Then PIR dot IRQ, brackets on, trigger equals capital P on the pin dot IRQ underscore rising, also uppercase, comma, space. Handler equals handler underscore interrupt. Brackets off. Okay, brackets change colour. Make sure everything's hunky-dory. Now we have a while loop. Okay, so it's while. Right, hang on. Just noticed. Good. Why that went like that. After the interrupt. Remember I said these indents are important. Take these indents out. Right. Just noticed that after the interrupt underscore pin equals pin, the tabs are no longer required. Okay, come down. While true, capital T on the true. That's our while loop. Colons, auto indent, if motion. If we pick up the motion, this is what I want you to do. Enter. Let's do a few enters so we bring it up a bit. Okay. You can see where we're at. All right. If motion, auto indent, print. Brackets on, quotes. Motion. Detected. So whenever we do this, we do a print, we do our quotes. Anything within these quotes will be printed. Right? Exclamation mark. Interrupt caused by. Okay. Colons. And close your quote. Right, brackets. Sorry, comma. And interrupt underscore pin. Small pin. Right, P on the pin. Brackets off. Enter. LED.value. Brackets on. 1, brackets off. All right, now we want to put a sleep time for our LED to come on. All right, once the motion detected, the LED.value equals 1, turns it on. And we want it to sleep or be on for 20 seconds. Brackets off. Enter. So after the 20 seconds, LED value, brackets on, 0, brackets off, turn off. All right, that looks okay. Enter. Print. Again, brackets on, quotes, motion stopped. Or you can put motion end, exclamation marks, quotes, brackets off. Then turn it all off. It's a motion equals false. Capital F on the false. Radio. So that's our code for this. That's our code for this. Hopefully there's no mistakes. We'll quickly go through the meanings. Quickly go through the meanings or how the code works. Okay. Use the interrupts. We import our classes, machine, import pin, time, import sleep. All right. Then we create a variable. This variable here called motion. And to start off with, we set it to false. Then we create a function called handle interrupt. This function will be called every time motion is detected. So every time motion is detected, this function will be called. All right. And it causes a class pin that will be passed when the interrupt happens. It indicates the pin caused the interrupt. Right. Then preceding that, we've got 2 objects. We've got our LED, that's an output, and our motion detector is an input. Right? And we set the interrupt by calling the IRQ method. Right? The IRQ method. And then finally, we've got the while true in the loop. When the variable is true, LED comes on for 20 seconds. After the 20 seconds, LED goes off and the motion is stopped. Good. Right. So let's have a demonstration. Let's have a demonstration. Hopefully there's nothing wrong with the code. Run current script. PIR isn't identified. Line 13. You just look at line 13. Right, PIR equals, oh, little typo. Got that. It's equals. Okay. Right. Stop again. And let's run it. Line 15. PIR. Trigger. End. Handler. Interrupt. Check this. Sorry about this, guys. We've been doing all right with our code, haven't we? PIR.IRQ. Brackets on trigger equals pin dot IRQ underscore rising comma, handler equals handler underscore interrupt. Handler underscore handler checking this, guys. Handle interrupt. Okay. So I put a handler. It's not, it's handle. Right. Let me just do a quick file save. And let's run it again. Right. Hopefully everything's hunky-dory. Okay, let's come over to our overhead. And what I'm going to do, I'm going to do some motion. And there we go. Okay. Motion detected, interrupt caused by PIR 14. Let me just go back over to that so you can see that. Down here. Motion detected, interrupt caused by pin 14. Pin 14, motion stopped. And the LED has gone out. Right. You know, with this technology, you could build a security light. It's exactly how a security light works. Just almost exactly the same, except obviously more powerful PIR and more powerful spotlight. You could make a security light. Well, there you go. I hope you found this lesson quite exciting. Okay, I did. Okay, all working. Yeah, we're moving on. We're moving on, getting more and more complex as the sessions go on. Anyway, thanks for watching. Hope you enjoyed this one. I did. I enjoyed doing it. Please, don't forget, give us a thumbs up and subscribe. And I'll see you in the next session. Okay, bye-bye, everybody. Bye-bye.